Hello, this is Michelle Ashburner, and today we're going to look at a few of the problems from our textbook. This is section 2.6, number 21, and in case you don't have the textbook, you can follow along right here. We're given the following curve. It's absolute value of x minus the absolute value of y is equal to 0, and you're asked to find three things. First of all, the x and y intercepts. Secondly, the book asks for the different kinds of symmetry, and we'll be looking at the even symmetry or the odd symmetry, but not the other kinds. And finally, it asks you, after you determine the symmetry, to sketch it. So, for part A, the x and the y intercept, we'll keep in mind that when we plug in y equals 0, we get the x-intercept. So plugging in y equals 0 gives us absolute value of x minus the absolute value of 0 equals 0. The minus absolute value of 0 is a fancy way of saying 0, so therefore we get the absolute value of x is equal to 0. And unlike any other number, when you have the absolute value of x is equal to 0, you can just flip the bars because 0 and minus 0 are the same. Spoiler alert. So therefore, x equals 0 is the x-intercept. Then, in a similar way, when we plug in x equals 0, we get the y-intercept. So as you can see, we plug in 0, we get 0 minus the absolute value of y is equal to 0, so right over here. And then if you just kind of rearrange for minus absolute value of y, you get this. And from here, you can conclude that the only way to make the right-hand side 0 is to choose y equals 0. So these negative signs don't really have much of an impact in this case. But all we've been able to get from A is that the point 0, 0 is on the curve. So that wasn't very helpful. It was kind of a warm-up exercise. So then part 2 is asking for the symmetry. So let's focus on even symmetry, or the symmetry of a graph across the y-axis. So a graph is even, or has even symmetry, if every time you see a point x0, y0 on the graph, then the point negative x0, y0 also lies on the graph. So the way that you would show this, given that you don't quite have a function of x, so you can't really sub things in as easily, is you would assume, first of all, that you did have a point x0, y0 that was on the graph. And if it's on the graph, then you can write this out, the formula for the graph. And then what you can do is you can say, well then, I can sub in minus x0, y0 and show that it gives the same thing. So because when you put a negative sign in with a number in absolute value, it doesn't affect the absolute value. In essence, the absolute value removes negative signs. So putting more negative signs inside it won't really make anything different. And so you end up getting that minus x0 in absolute value minus y0 in absolute value is 0, which means that the point negative x0, y0 is also on the graph. Therefore, it's even. We just showed it's even. Then we want to show it's odd. So this is a very similar argument. An odd graph is either looking at a rotation about the origin of 180 degrees, getting the graph to look the same, or a double flip, a flip in the y-axis and a flip in the x-axis, one after the other. And I like to think of the double flip this time, because then we can use the definition that if your point x0, y0 lives on the graph, then so will negative x0, negative y0. So you start out by saying that we assume that there is such a point, and it looks like this, and when you sub in your negative x0 and your negative y0, you'll end up being able to make the negative signs disappear. Any other questions on that, let me know. Try that little part yourself. The curve is actually odd as well. It has a lot of symmetry. Now comes the fun part where you get to sketch it. Okay, so this is what I'm going to do. I'm going to rearrange so that I have the absolute value of y on the left side equals the absolute value of x on the right side. So I'm pretending it's sort of like a function so I can deal with it a bit more easily. And so what I have here, two cases. So the first case is, let's suppose that we're looking at the part of the graph where y is greater than or equal to 0. So this part here. Then what's this expression going to look like? Well, we know with absolute value that when you have something positive in here, you can take the bars away and nothing happens. That's the definition of the absolute value function. Therefore, you can write just simply y is equal to the absolute value of x. So for the cases where we're looking at all these positive y, you get this graph, just normal absolute value of x. However, when y is negative, so you're looking at these kinds of y's, what kind of curve will you get then? Well, then the absolute value of y will have to be minus y, which is a bit of a mouthful, but we're really just saying that if you have something less than 0 in absolute value and you want to take the bars away, by definition, you put a negative sign in front of it. So then, if we lift the bars this time, we get negative y equals the absolute value of x. Rearranging, we get y is equal to minus the absolute value of x, which is just absolute value of x flipped upside down, or in other words, a vertical reflection. So you get this part for all of these y's. And then you can conclude that your sketch of the entire thing is both of those graphs glued together. This is not a function, and if it was magically a function, it most certainly wouldn't be one-to-one. So that concludes that question.